Hey class, some of you have been asking questions about problem number 3 on the workshop, so I thought I'd make a video for you all. You can see here my beautiful drawing of my two rectangular cars. They're both heading towards one another with the same initial velocity. We're going to go ahead, I'm going to call this car number 1, and the one over here I will go ahead and call car number 2. So we're told that the initial for car number 1 is the same as the initial velocity for car number 2, which is given as 15 meters per second. So, we're also told, not the mass of either vehicle, but we're told that there's a mass ratio of the two, that is, car number 1 has a mass of m, while car number 2 has a mass of 3m, as shown in our problem. So we're going to be looking at the idea or the concept of conservation of momentum, where we know our initial momentum as a vector is going to be equal to our final momentum. And adding to that, or breaking this down into component form, you could say that your initial momentum in the x direction is going to be equal to your final momentum in the x direction, and your initial momentum in the y direction will be equal to your final momentum in the y direction as well. So if we look here, we can see clearly that our initial momentum in the x direction is really just going to be equal to a single m multiplied by v initial 1. That's the only thing moving in the x direction initially. And so we can also find our initial momentum in the y direction is only going to be a result of the vehicle with 3 mass. So it's just going to be 3m multiplied by v initial 2. Now these v initials are both 15 meters per second, but for now I'm going to leave it in variable form. So in order to use either of our momentum equations to try to solve here, we need to look at what happens after the collision. So I redrew my picture down here with the collision occurring, and now we can observe that these two cars, since the problem tells us they become entangled, then they're going to move together with one velocity off at some angle. And so this angle here, maybe if I kind of made an x and y axis at this point of the collision, this angle maybe we would draw here and define as the angle theta. Okay? And some of you, the problem wasn't real specific. Some of you may have put your 1m car on the y and your 3m car on the x, and that's perfectly fine. The only difference that you'll find in your end result, the magnitude of your velocity should be the same, and your angle will just be 90 minus my theta, and I accept both answers as being correct. So this final velocity here is going off at the angle theta, and we can use that to determine our final momentum in the x and y direction. So let's go ahead and start by breaking that final velocity into its components. So the final velocity in the x component, we can observe, will be the final velocity multiplied by the cosine of our angle theta, and the final velocity in the y direction will be equal to the final velocity multiplied by the sine of the angle. I hope you guys notice also that I'm using purple, the combination of blue and red, to represent the final velocity of my blue and red cars colliding. You're welcome. Anyway, so now what you can do is you can look at your conservation of momentum by putting everything together, and to help you do that, I'll go ahead and define our final momentum in the x direction. We can see is going to be equal to the total mass. So what's the mass of the two cars once they're stuck together? Well, it's 3m plus 1m, or 4m, multiplied by the final velocity in the x direction, which is v final cosine theta. And similarly, we can look at the final momentum in the y direction, because it will be equal to 4m multiplied by v final times the sine of this angle theta. And so now, if you put together setting p initial x equal to p final x and p initial y equal to p final y, you should be able to have two equations with the same two unknowns, v final and theta. You're not given mass, but as you notice, every single one of our terms contains a mass unit, and so the m's will actually cancel out. So hopefully that gives you a good start, and I'm guessing you all can solve from there. Let me know if you have any questions, and hope you're having a box-worthy weekend.